Pre-calculus, section 2.4, dividing polynomials, remainder and factor theorems. Today's objectives: use long division to divide polynomials, probably the hardest thing we have all day. Use synthetic division to divide polynomials, a lot easier. Evaluate a polynomial using the remainder theorem, quite simple. And then use the factor theorem to solve a polynomial equation, also quite simple. All right, so if we can get past this first bullet point, the rest of this is going to be fairly simple. Okay, so here we're going to have a long division of polynomials. We're going to be dividing a polynomial by a binomial in this case. And I'm going to remind us real fast of long division. So if we have 240 and we want to divide this by 4, we first ask ourselves, how many times does 4 go into 24? And the answer is 6. Then we multiply 6 times 4, which gives us a 24, but we have to subtract it. And then we get a 0, so we have to bring down our other 0. And then we ask ourselves, how many times does 6 go into 4, or how many times does 4 go into 0, which is 0. Then we have to multiply the 0 times the 4 and subtract it. I know it's kind of silly. And then we get our final answer. Well, we're doing very similar things here. So let's just go ahead and get cracking. We're going to get an x plus 4, and then we're going to have the x squared plus 8x plus 16. So we have to be careful here. We need to make sure that every power of x is being represented from highest to lowest. Our highest is x squared. Our next highest is just power of x, and then power of 0x. So here we're good. Later on, we'll have to figure out what to do there. All right, so our next step here is to see how many times this x goes into x squared. If we don't see it right away, we can just go ahead and divide them. X squared divided by x is equal to x. I'm going to write that x above my power of 1x because I like to line these things up because they help me to realize if there's been a mistake. Now what we need to do is we need to multiply x by x plus 4. And because if you recall we need to subtract, I'm going to suggest we multiply by a negative x. Get that subtraction taken care of right now. So that way we don't forget and have some terms that subtract, some terms that don't do what they should. And yeah, so here we're going to get x times x, which is a negative x squared. They're going to cancel. Looks good. Negative x times 4, which gives us a minus 4x, which gives us just a 4x plus 16. And we do it again. We see how many times does our x, in this case this x right here, go into 4x. And hopefully we can see that it just goes in 4 times. So we're going to do a plus 4. Notice that my 4 is above the numbers or the constants. And then we'll just go ahead and do negative 4 times x plus 4, which gives us a negative 4x. And then a minus 16. Oh, good. There's 0 remainder. So in this case, our answer is just this x plus 4. All right, make my face disappear because we've got lots of words here. Long division of polynomials. Arrange the terms of both dividend and divisor in descending powers of any variable order. So highest power on the left, lowest power on the right. Divide the first term of the dividend by the first term in the divisor. The result is the first term in the quotient. So that was the first thing I did there, where I had x squared divided by x, and we got x. Step 3, multiply every term in the divisor by the first term in the quotient. So that was that second step. Write the resulting product beneath the dividends with like terms lined up. Subtract the product from the dividend. So I kind of here multiplied steps 3 and 4 by putting the minus sign there. Why? Because I've seen many, many mistakes among students, and I realized if I just combine those into one step, we have fewer issues. Bring down the next term in the original dividends and write it next to the remainder in the new remainder to form a new dividend, and then use the expression as the dividend and repeat this process. So basically we just do everything that I did. This will occur when the degree, okay, so this is something new here. We will continue this process until the degree of the remainder is less than the degree of the divisor. So we haven't seen an example of this, but we're going to. Or the highest exponent on the variable in the remainder. Okay, so we'll continue until what's being divided has a lower power than what is doing the dividing. All right, let's put my face back on. Okay, so long division. So first off, we need to rearrange this. This is not in the proper form. So we're going to have our x minus 1. I'm just going to hold off on making the house for now. X cubed minus 2x squared minus 5x plus 6. And let's do the same thing over again. How many times does x go into x cubed? It goes in x squared times. Combining steps 3 and 4, I'm going to get negative x squared times x minus 1, which gives us negative x cubed plus x squared. So you can kind of see here how all of my x squareds are lining up. And even more so, because when we do this subtraction, we just get a negative x squared. We bring down our negative 5x, and we continue. How many times does x go into x squared? It goes in, this time, negative x times. Now you see all of our linear x's are lined up. So we can now do the opposite of that. So we're going to actually do a positive x times x minus 1. Which gives us an x squared minus x. And then we get a negative 6x. We bring down our positive 6. And we do it one last time. So here we're going to get x going into negative 6x, negative 6 times. So we'll have a 6 times x minus 1, which is a 6x. Oh, cool. Minus 6. Everything cancels out. There is our answer. Holy goodness. The division algorithm. Let's turn my face off again. All right, if f of x and d of x are polynomials with d of x is equal to 0, or d of x is not equal to 0, the degree of d of x is less than or equal to the degree of f of x. Okay, so they're saying here that this right here has a power less than or equal to f of x. The equal to is because we could be multiplying it by a constant, a number, in which case the power of x will not be increasing. The remainder r of x equals 0, or it is degree less than the degree of d of x, or r of x is equal to 0. Basically, our remainder has to have a lower power than d of x. So whatever the power of r of x is, this could be like n minus 20. This could just be like n minus 19. Minus 20 is less than minus 19, so its power is lower. We're going to have an example. Let's move on. Okay, we're going to be dividing. So in this case, notice for a moment here, we have x cubed and x. We don't have an x squared term in here, so we're going to need to inject that. We're going to have a 9x cubed plus 0x squared plus 2x. I'm going to go ahead and add a plus 0. We might not need it, but I'd rather have it. then have to make my house bigger again. Let's lower that. Then we'll have our 3x minus 5. Same process. We can do this. All right, 9x cubed, 3x. That goes into there. Let's see. Well, let's just do it on the side here. 9x cubed over 3x. The 9 and the 3 reduce. And then, okay, so we get a 3x squared. So there's a reason why I suggest we line up the variables. Now we see that the x squareds are lined up. So had we not put that 0x squared in there, we could have been getting pretty lost. I can turn my face back on. Okay. All right, so let's do this. Negative 3x squared times 3x minus 5 gives us a negative 9x squared. 9x cubed, I should have said. This gives us a plus 15x squared. And then that just gives us a 15x squared plus 2x. See how many times 3x goes into 15x? Well, that's just simply 5x times. Try it if you don't believe me. So we're going to get a negative 5x times 3x minus 5, which gives us that negative 15x squared plus 25x. Yeesh. Okay, so we're going to get a 27x. Going to bring down the 0, which, yes, I guess we did need, because this, which I'm about to highlight, has the exact same power as the 3x, not one lower, so we do need to actually do some more math here. All right, 3x goes into 27x 9 times. So we're going to get a negative 9 times 3x minus 5, which gives us a negative 27x plus 45. And we get a remainder of 45. 45 does not have the same power as x. It's lower by 1. It's actually a 0. It's an x to the 0th power. So here's the thing. Now we need to write our remainder. Our remainder is going to be a plus 45 over 3x plus 5. When we do our remainders, we don't write an r with the number. We need to rewrite it as a polynomial. In this case, it's a rational thing here. So that's our answer. It's big, it's ugly. We're in pre-calculus. Deal with it. Okay, now life's going to get easier. Much, much easier. Synthetic division. To divide by x minus c. So in this case, notice, we need to keep in mind here that this is a linear term. The power of x is only 1. This is the only time we can use synthetic division. If it's not a linear thing we're dividing by, if it's not a line that we're dividing by, it's not going to work. Arrange the polynomials in descending orders of powers with a 0 coefficient for any missing terms. Okay, we did that earlier, except we can change things up a little bit. Write c for the divisor from this x minus c. So if we do, watch this. That's not what I wanted to show you. X minus c equals 0. We get our x is equal to c. So we do the opposite of whatever the number is. Write the leading coefficients on the dividend at the bottom row. Multiply c times the value just written. Okay, let's go ahead and write this down. I'll give you a few moments. I think it'll just be easier to go through the process. It's one of those things that you just kind of want to see. So if you need to pause and write, I'm going to move on. All right. I noticed that. Okay, so we need to rewrite this as 2x cubed minus 4x squared plus 0x plus 5. Now using our synthetic division, we're going to use a 2 here, because if we set that equal to 0, we get a 2. So I'm going to make this backwards L. I'm going to put a 2 there. I'm going to write all the coefficients, 2, -4, 0, and 5. Step 1, bring down the 2. Step 2, multiply 2 times 2, and then add that right there. So we're going to get a 4. Now we're going to add -4 and 4 together and get a 0. We're going to do, once again, this 2 times 0, and that gives us what goes here, which will be a 0, which gives us another 0. And then that 0, well, I'm not going to multiply that because it's just going to give me another 0, gives me another 0, and then we have a remainder of 5. Okay, so here's the thing. Our power of x was x cubed. So when we rewrite our answer, it's always going to begin 1 power of x lower. So we're going to get a 2x squared plus 0x plus 0 plus 5 over x minus 2, or simply just a 2x squared plus 5 over x minus 2. So our synthetic division is a much easier process, but you need to keep in mind that the power of x is always 1 less in our final answers. Okay, don't let this go unnoticed. What are we not noticing here? The remainder theorem. If a polynomial function f of x is divided by x minus c, then the remainder is f of c. Okay, here is our remainder theorem. Super easy. We're going to be done with this in like 10 minutes. No, less than that. Okay. All right, so here we're going to go ahead and divide these polynomials. So let's do this. Okay, so notice first that we have power of 6, 5, 4, no 3, yes 2, no 1, no constants. So I'm going to go ahead and get this started by doing a 4, and then 4, -25, 35, 0, 17, 0, and 0. As a reminder, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then our constants. So let's get started. Bring down the 4. 4 times 4 is 16. -25 plus 16 is -9. 4 times -9 is -36. That gives us a -1, a -4. I'm just multiplying and adding, folks. I'm not doing anything special here. 0 minus 4 is -4. Gives us a -16. Gives us a +1. Gives us a 4. 4, and then 16 or 16. So we're using the remainder theorem. So our remainder here is going to be 16. So what is f of 4? Is it in fact equal to 4 times 4 to the 6th minus 25 times 4 to the 5th plus 35 times 4 to the 4th plus 17 times 4 squared? Well, let's find out. All right, and then I talk a lot when I do these things. I made an error. Okay. Made a few errors. Okay, 25. right, look at that. My calculator, if you could see that, let's see if you can. All right, it says 16, whatever. Okay, so all this ends up equaling to be 16. So that's the remainder theorem. If you evaluate the function at a number, in this case 4, it will give you the remainder of if you were to divide it using synthetic division by that number. This could be a quick way to check for zeros without having to do a whole bunch of synthetic division. We'll see. Oh, a blank slide. Look at that. Oh, another blank slide. Oh, another blank slide. Oh, I guess we're done. Okay, that was unexpected. Well, let's just end there.